All right, so in the last video, we left off about ready to describe what happens if your position graph is not a straight line, either a flat straight line or a sloped straight line. And so let's get right into that one. Let's use this for. All right, so position time graph and velocity time graph. Leaving room for the future acceleration graphs. Now let's just get ready for more. Yeah. In the name of future something good about the future. Can't think of the word right now. That's okay. It's not that important. All right, so and we get that color. Okay. Well, is this going to be the correct? No, I don't want to do this one yet. Let's change to this one. Ah, yeah. Okay. So let's say we start down in negative land. All right. Down in negative land. And we start moving up towards positive land because it's a beautiful land with trees and positive leaves. Anyway, so in moving towards positive land, we start out slow because we're not quite sure we really want to get there. We haven't seen what it looks like yet. We're still in negative land, and negative land is scary. We've heard positive land's good, but we're not quite sure yet. It could be all a trick, right? So we're hesitant. So we're going to start off slow. How do we know we're starting off slow? Well, we discussed last time that that the slope of your position graph determines your velocity. I didn't really go into extreme detail about that, so let me maybe take a sidetrack. Slope is rise over run, right? And your rise on a position graph going up is your change in position. And your run on a position graph is your change in time. And you should remember that velocity is change in position divided by change in time. So that's really what's going on in terms of slope and how slope and velocity relate. So the slope down here isn't very steep. One way of looking at that is thinking of this as like a hill. And if you're walking up this hill, if you're a little person, let me draw a little person here. You're like a little guy, like, oh, going up the hill. Ah. Right? It's pretty easy to walk on a hill that's this steep. But when you get to about here, you're going to start breaking out the rock climbing gear, right? Because this is pretty steep stuff. So that's one way of looking at it. You could also, I have no arms. You could also think of it as change in position over change in time. So to go from a time of 0 to a time of about here, how much has your position increased? You've gone from about here to here. Not much at all. You've gone up just a tiny bit. But what about the same time interval, which is about this long, from here to about here? So that's roughly the same time interval, time of about that long, time of about that long, right? But what's our position change in that time interval? Well, we start at this position at this time, and at this time we're at about this position. And as you can quickly see, we've covered way more distance. We've gone from here on our position axis to here. Look how much bigger this distance is compared to this distance. So by looking at the analysis that way, you should definitely be convinced that we're traveling faster up here. Okay. So roughly, what does our velocity look like? Well, we are moving in the positive direction. And so direction, we're moving towards positive land, right? So direction-wise, our velocity graph has to show that. And that means we have to have positive velocity. And we're always moving in the positive direction, so our velocity graph must always be positive. Okay, so that means whatever I draw over here has to be above this line. It has to be up here in positive velocity. Okay, and we just got done saying that we started off slow and we're speeding up faster and faster and faster. In fact, let's assume we start at rest because, you know, we were thinking about walking to positive land, and while we were thinking, we were just standing there. So what would that graph look like? We start at rest, 0 velocity, and our velocity is going to pick up. We're going to speed up. So velocity is getting higher, and we still always have positive velocity. How do I know that this graph is straight? Good question. We can't tell just by looking at this graph because this graph could be anything. In fact, I'm guessing the curvy pen feature I'm using to draw this is not making a parabola, so I'm guessing technically this should not be a straight line. But let's assume that this is a parabola. And when I say parabola, you should hopefully be thinking this. T. Oh, this looks so familiar. Whoops. 1/2 a t squared. When I say parabola, hopefully your mind has moved to the equation and you're like, ah, this is the parabolic term right here. That squared here, parabola. T squared, parabola. If you didn't think that immediately, that's okay, but I wanted to bring this up so that from now on you think about that. Let's get rid of this. Okay. So if this is parabolic motion, then your velocity is going to be constantly increasing. This is going to be a constant slope. Okay. Well, what are we doing for time? Pretty good. Let's say instead we start up here and we move back in this direction. What's a good story I could tell? Why would one want to be in positive land and go to negative land? I leave that up to you to come up with your own story. I can't think of one. I'm always trying to get to positive land myself. All right. So what would this graph look like? Well, again, we're starting off slow because our slope is not very steep here. You can think of it in the hill, using the hill analogy, or you can analyze your change in position over your change in, over a consistent change in time. And you can see it's steeper here. So we start off again with a slow velocity, dare I say 0 velocity at rest. And we're picking up speed. But this time we're moving in the negative direction. And so our velocity has to be down in the negative, and our velocity is getting higher. Don't let this confuse you. Let me write some numbers in here. Down here, let's say this is -5, and up here is +5. Um, the numbers get, even though they're negative and they get more negative, they do get higher. -5, -6, -7, -8. They do get higher going down this way. And so um, this negative here only means direction when we're talking about velocity. So our speed here and our speed here are the same. We're both going 5 meters per second, let's say, if our units are meters and seconds here. But the negative tells us we're going in the negative direction at 5 meters per second. And here we're going in the positive direction at 5 meters per second. Uh, this tends to be tricky thinking about this, but you need to get that clear. And 2 more graphs. Let's say we start over here in negative land, and we know beyond any doubt that we want to get to positive land. So we start off at a dead sprint. We're like, I'm coming, positive land. Wait for me. Of course, starting at a dead sprint, and you're maybe a little out of shape because you've been in negative land for your whole life, and you're just like sitting on a couch doing nothing. So you're probably out of shape. So you're gonna be running, but then you're like, I'm tired. And once you reach positive land, you're there and everything's good. So you're just gonna slow down, and then you're gonna stop and take a breather. What does a velocity graph look like? You're starting fast, so you're either going to be up here at a high positive velocity or down here at a high negative velocity. And if we're moving in the positive direction, that leaves this graph. We're going to start up here in positive velocity land, and we're going to do that until we come to rest. We're going to rest here because we're tired from running, and resting is zero velocity, which we've approached here. Alright, and alternatively, for some strange reason, you're tired of all the fluffy goodness of positive land, and you're like, I need some action in my life. Let's go to negative land where people are always trying to attack me. And so we start off at a dead sprint, and we reach negative land. And of course, for some reason we've stopped, even though people are trying to attack you in negative land. You stop momentarily. Maybe you want to be attacked. So, what does that look like? Well, you start at a high speed, so you got to be in this area at high velocity, and you're slowing down until you come to a stop. Slowing down until you come to a stop. In terms of slope, your slope is getting lower and lower and lower and lower until your slope is 0. Cool. So we've covered all those graphs. Let's add acceleration into the picture in the next video. All right, see you soon.